quick introduction about myself. Myself, Mona Patel. I am serving as a Chief Technology Officer at NEPRA Environmental Solutions Technologies Private Limited. We are actually serving software as a solutions in sustainability domains. And apart from that, I am a solution architect by profession. So we are delivering all our softwares and we do have all our in-house products. And we do deal with mobile technologies, web-based technologies, and we maintain hybrid cloud infrastructure on on-prem as well as on AWS cloud. So I would like to keep this session very much interactive. So first I would like to know about my audience that how many of you are well aware about AWS security services? I mean having a theoretical knowledge of AWS, specifically security services. Okay. And how many of you have actually implemented those services in a very practical manner, having hands-on experience on practical projects, delivering to clients? Okay, so I'll keep my pace of speech accordingly, so you people would have better idea. Okay, my today's topic is related to building a secure and resilient architecture, how we can make our architecture more resilient. So first I would like you to know about what is architecture. If I would say in layman terms, architecture is your foundation or is your base on which your entire structure will stand. So in technical terms, our architecture stands for making our entire application the way which everyone can operate in a very secured and feasible way. And resilient in terms of it should be able to handle all kind of disruptions. If in future occurs any kind of security breaches are there, then it should handle everything very efficiently. So for that, before going to that, I would like to talk about few of the AWS services which are related to security domains. And using this, I have created one classic 3-tier architecture which you can utilize for your day-to-day business operations. Okay, so to start with AWS Certificate Manager. What is ACM? So ACM is basically a certificate service provided by AWS where you would be able to provision, create, rotate, maintain your all SSL TLS certificate. So what is SSL TLS? So SSL TLS are basically industry standard protocols for encrypting your network communications and for making your data secured at transit. While your data is sitting at any of your storage location or while you are navigating through your data, it must be secured at all times. So ACM provides you the specific service for maintaining your certificates in transit. So you can integrate these certificates at different levels. Okay, now what is symmetric key and asymmetric key encryption? Anybody? What is the difference between symmetric key and asymmetric key? You must have heard about cryptographic operations, right? So whenever you are using any of the cryptographic operations, there must be certain keys that called public key and private key. If you are using same key for encryption as well as decryption, that is called symmetric key encryption. And if you are using different keys for encryption and decryption, that is called asymmetric encryption algorithms. So these all are the services, AWS services, with which you can include ACM, that is Elastic Load Balancing, CloudFront, Beanstalk, Nitro Enclaves, and CloudFormation. 3 kinds of certificates which you can use within your ACM. You can create your public certificate, private certificate, or you can import certificate from third-party services as well. Second service is KMS. What is KMS? It's a key management service. So basically it's a key infrastructure management which is managed by AWS. So probably you don't need to, worried about what are the key management algorithms which you need to take care of. AWS takes care of for that on behalf of us. So there are certain things which is provided by AWS. You can have customer managed key as well as AWS managed key. So for customer managed keys, you are responsible for creating, rotating and managing their key infra. Whereas AWS managed keys will do those things on your behalf. Okay, so these two are the key stores which are available nowadays, external key store and custom key store. For external key store, you would be able to meet your regulatory requirements using KMS. And KMS will store entire thing outside of the AWS infrastructure. Whereas custom key store, you can integrate your entire cloud HSM infrastructure within AWS. So that is your custom key store, and all cryptographic operations are performed solely in the AWS Cloud HSM cluster, which you own and which you manage. And one point to remember, that custom key stores are not available for asymmetric key KMS keys. These all are few of the snapshots of AWS managed KMS keys, which you can use for different kinds of criteria. Data encryption keys. So as you can see that KMS can store this key within its infrastructure. So whenever you are using any kind of encryption algorithm, there is one data key. Again, to make it more secure, you can encrypt that data key as well. So that encryption of data key can be performed within KMS, and you can utilize that KMS service for encryption and decryption algorithm. You must have to use and manage the data keys outside of KMS. This is the most important thing related to keys, which is rotation of your keys. That how frequently you need to rotate your keys in order to make it more secure. So if you are using customer managed keys, then as I said, that you are responsible for managing entire key infrastructure, whether it is rotation or anything. And if it is AWS managed key, then you would be able to view those keys, but you won't be able to manage those keys on your behalf because AWS is taking care for that. This is the algorithm for key rotation. Whenever you are actually rotating keys using automatic rotation, in that case, the key material used for encryption will get rotated at the frequency which you have set. But key ID will remain same. So if you are using any kind of key ID within your application code, you don't need to go and change your key ID every time. Whenever you are changing that key material or whenever you are rotating your keys. So we have to always make sure that we need to use alias. If we are not using this kind of rotation, then we have to use alias of our keys. Otherwise, you have to go and change your application every time whenever you are rotating your keys. This is the same thing for automatic key rotation and manual key rotation. So what you can do with automatic key rotation, properties of the KMS key including key ID, ARN, region, policy and permission. They do not change when the key is rotated. Wherein in case of manual key rotation, it will get changed. So every time you have to go and change your application code. That is the reason why we have to use alias of our keys, so that you can use alias directly in your application code and it will be referred accordingly. So you don't need to go and change everything at the time of rotation. So this is the application where we have used alias. This is old key and this is new key. The alias is associated with the new KMS key whenever you perform rotation. This is something snapshot related to the key policy for administrative actions which you can provide to any user, that what are the actions he or she needs to be capable of related to KMS. Whether they can create, update, enable, revoke, delete, any kind of operations for administrative access can be possible with the help of this policy. This is the cryptographic actions for multiple policy statements where KMS would be given permissions for describing, generating, encrypting and decrypting keys. Okay, this is permissions can be specified for delegating use of the key to AWS services, where grants are useful for temporary permissions. Whenever we are saying list of privilege of list permissions, in that case you have to use grant. So it won't give permissions permanently. That would be temporary permissions. So you can assign these grants, list grants, create grants, anything you can do with the help of this policy statement. Cloud HSM is the next service which we will utilize within our architecture. So what is Cloud HSM? It's a hardware security module based on AWS. It's basically a physical storage where you would be able to manage your cryptographic operations, as well as it will provide storage for your cryptographic keys as well. So it's a single tenant application within AWS. It is not getting shared with multiple tenants. So that is the basic difference between cloud HSM and KMS. That will reduce your operational overhead related to time consuming task of KMS management infra. So you don't need to like manage your entire HSM clusters whenever if you need scalability. So this HSM would be able to add and delete HSM clusters on demand whenever you need. It is based on US FIPS 142 level 3 validated HSM. It's again a US based security standard which you need to use for any hardware security modules. So this is on level 3, whereas KMS can be implemented at level 2 and very few cases in level 3. Macie. What is Macie? So Macie is actually a AWS managed security and data privacy service. It uses machine learning and pattern matching algorithms for discovering and monitoring and protecting your sensitive data on S3. So using Macie, you would be able to identify your PII information, that is personally identifiable information, your PHI information, your credit card, debit card related information, any sensitive information can be observed and monitored with the help of Macie. It's specifically related to the exposure of your S3 bucket, using which you would be able to monitor and generate a trigger based on the Macie's notification. As you can see that on S3 bucket we have already integrated Macie that automatically discovers S3 buckets and it will analyze buckets using machine learning to discover any sensitive information, and based on that you can set your CloudWatch alarms, triggers, and SNS notification can be generated based on that. Config. What is AWS config? So config is nothing but it provides you the rules for your configuration. So whatever the configuration of your existing resources and how it should be, that is the difference between your existing configuration and what is the desired configuration. Based on that, it will generate an alert and you can take an action accordingly. So where config can be utilized on EC2 instances, ELB, RDS instance, SNS, everything can be clubbed with the help of config. Whenever there are any changes related to configuration, at that time AWS config will be able to generate and raise a notification accordingly. These few are example rules. For an example, like S3 bucket server side encryption enabled. So this will check that your Amazon S3 bucket either has S3 default encryption enabled or that S3 bucket policy explicitly denies put objects which are not encrypted. So accordingly you can put as many rules as possible, whatever you want in terms of security mechanisms. Amazon Inspector. So Inspector is nothing but it is related to vulnerability assessment solution. You can use your agent or agentless services also available with the help of Inspector. So basically there are two things, network assessment and host assessment. Whenever you are using network assessment, it will check whether your network is reachable or not. It will also check your port, but it will not go on your application, assess your application for the common vulnerabilities like software breaching or any kind of web exploits like SQL injection, cross-site scripting. These things won't be checked if you are not using agent for that. So you have to compulsory install Inspector agent on your EC2 instances as well. If you want to scan your container images in ECR, Elastic Container Registry, that is also possible. As I said, this requires an agent auto install with SSM run command. Whenever you are using SSM, at that time agent will get automatically installed on your EC2 instances. WAF, Web Application Firewall. These are some rules which you can use to block or allow your website traffic or web request. This can be based on your IPs, this can be based on your HTTP header, HTTP body, or any kind of algorithms which you need to integrate within web request. So these are rules based on your IP settings and everything. There are common criteria which you can use with the WAF. So WAF can be integrated with CloudFront, ALB, API Gateway, and AppSync. Thing to remember, WAF cannot be integrated with your network load balancer. It works at presentation layer, level 7, so it will be at ALB only. These all are components related to WAF, which is Web Access Control List. You can create your own control list for which protection of your AWS resources can be created. Rules. Again, you can allow, block or deny whatever the criteria you want to put, and if that criteria gets matched, request will be allowed or it will be denied. IP sets and regular expression pattern set. And IP set provides a collection of IP addresses and IP address ranges that you want to use together in a rule statement. And regular expression, if you want to make it more complex or if you are having a certain level of complexity within your IP set range, then you can use regular expression pattern set in that case. These three are the components related to the WAF criteria, where you can actually count, allow or block. WAF allows the request to be forwarded if it AWS resource for processing and response. It can block as well the request based on your criteria, and accordingly 403 error will be raised. These are the few match statements provided by AWS for specifically for WAF, where geographic match, IP set match, regular expression set, size constraint, SQLI attack, string match and cross-site scripting attack. This you can integrate with your web application firewall. Shield. Shield is basically a AWS managed distributed denial of service protection service, where it will safeguard your application running on AWS, which always on detection and automatic inline mitigations. There are two types of tiers available for Shield, standard and advanced. Standard is free by default and it can be integrated with your CloudFront, because CloudFront automatically enables this standard Shield whenever you are using as a custom origin. And for advanced, you have to pay a hefty amount because it will take care of additional DDoS attacks. Okay, now this is the architecture. These 8 services I have utilized for making this classic architecture of business application, where you can see there are primarily 2 instances in private subnet, 2 instances which are in auto-scaling group. As you can see, we have public subnet where we have launched our application load balancer, and it is front-end by CloudFront. So I want each and every request to be carried forward with the CloudFront only, and it should not circumvent and go directly to ALB. So here there are certain criteria which I can put to integrate this so that any web request cannot go without CloudFront. So I will put certain level of HTTP request headers which would be verified at the level of ALB. So very first service which I would utilize is ACM, where this SSL TLS certificate would be integrated on CloudFront as well as on ALB. You can integrate on EC2 instances as well, but it will be little bit more complex. So ALB will terminate your SSL TLS and you can again own your certificate on EC2 instances, but it is not required because this is a classic architecture. It can be done on ALB and CloudFront as well. Then we do have a WAF and Shield. So as I said, Shield is enabled by default whenever you are using CloudFront. WAF can be integrated to check your common website exploits like cross-site scripting and other SQL injections. Then we do have config, which would check your actual configuration of resources based on desired configuration. Config would monitor your ALB as well as or your S3 bucket, that it should not allow any of the objects which are not encrypted to maintain the security at rest. So config can be integrated with S3 ALB and again with inspector, and based on that SNS topic we have integrated to raise an alert. KMS we have integrated with the EBS volumes which are available with EC2 instances. So you can make sure that all volumes are encrypted using cryptographic keys which we have stored in KMS. This is a very classic architecture. It is not that this is the world's best secured architecture. There is always a chance of improvement. But these all are the basic services which you can utilize in day-to-day basis. And this is related to business criteria where your each and every tier has different mechanism. So in order to implement your secure multi-tier architecture, you have to adopt a layered approach where each and every layer like web presentation layer, web tier, application layer and database layer has its own security controls. They are having their own security controls along with network isolation, strong mechanisms for authentication and authorization, then data encryption, this kind of things, and again, security best practices for your coding standards as well. So these all are the key components which we have to take care while we are maintaining this classic architecture. So very first component is network isolation. So what do you mean by network isolation? Basically, it is used for isolation of your each and every tier so that your tier can communicate with each other in a very secured way. So authentication between tiers is also mandatory. So whenever if any of your tier is getting compromised, there is no room or no space for unauthorized access to other tiers. So that's why that is the reason why we have to integrate that inter-tier authentication as well. Then comes your strong authentication mechanism where you can implement your MFA, multi-factor authentication for user access as well. Role-based access control you can also integrate where people would be provided rights based on their roles on applications. So list of privileges will be given based on that. And yeah, one tier will identify authenticity of the actual user, whether he or she is allowed to get into my EC2 instances or not. Based on that, rights would be provided. Monitoring and logging can be integrated where you would be able to track unintended action, unintended network exposures, any kind of unintended activities you would be able to measure, and that can be triggered. In case of any web exploits or anything happens, then that can be triggered with the help of your these mechanisms of security standards. Then regular security updates is also required where you have to make sure that all your software components including your operating system, then your frameworks, your database, those all things needs to be updated based on latest security patches. There should not be room for any kind of hacking or any kind of unintended access or anything. Because security is the most important whether you are in the cloud or you are outside the cloud. Based on that, your entire application will work. Because right now in practical domain, clients are demanding that they have to, they need entire application on their server as well as they ask to host on our server. So in that case, we have to make sure that whether we are using dedicated instance, we are using hosting separately, dedicated host is there, shared instance is there. Based on that, you have to keep track of your all activities. And at last, as I said, this architecture is a very classic architecture. There are so many other services of AWS which you can integrate with this architectures. But yes, this is the primary agenda of this entire resilient architecture which you can integrate within your day-to-day business operations. And you have to make sure that this architecture aligns with the industry security standard and regulations. Because that is the thing which right now clients demand. Whenever you are using hosting on other servers, like they are having their on-prem server and they will ask us to host entire application on their server, then you have to be responsible for maintaining safety and privacy of your data whenever you are deploying on their server. Yeah, so that's it from my side. Any questions? Yeah. Any question? Thank you. Thank you very much for your time. Any questions?
Hello. Yeah, just one question. This is here.
Yeah, hi.
Yeah. So all these architecture, like as a application, say when it comes to deployment, that is when it will be there, right? So by default, Amazon doesn't cover all these security.
No, because AWS prefers to have shared responsibility model. So only AWS will not take responsibility of the entire security. Okay. We have to take care of our application on ourselves. So AWS will take care of the actual underlying infra, okay, wherever you are using their physical servers, any related to the software racks, Those things Amazon will take care of. But yeah, again, security in the cloud is our responsibility. So we have to make sure all our data are encrypted at rest, transit, and as we talk about that, it should be very much secured in SSL, TLS certificate should be up to date. Those kind of things which we have to take care of.
So all these layers you mentioned, those are flexible, for the company to choose, is it?
Of course,
okay.
yeah.
Okay.
Because some companies prefer to go with two-tier architecture.
Yeah, exactly.
Yeah.
That's what I was.
And this is three-tier architecture. So we have to be flexible that way.
Thank you. Yeah.
What's your opinion about Amplify, AWS Amplify?
Amplify, to be very honest, we have not used on our regular application deployments. But yes, we would like to explore it in detail. Within our architecture, we haven't integrated yet AWS Amplify.